CAD is used for is a CAD software used to, draw three-dimensional pictures, things that can be printed. But we can actually do electrical circuits with this. So the way this screen looks, we're going to come up here and we're going to click on this box right here, which is the circuit view. And then these are all the components you can actually put on your screen. There's a basic components, and then there's all. So I would have you switch to all. And then these are all the parts that you can put in a circuit. So if you've been to my classes, one of the things I start off with is we start off with basically a 3-bulb set. So we're going to put 3 bulbs on the circuit, okay, on the screen. And then you're going to go and wire those together. So you simply click on them, bring them over here, and drag them in place. We are going to put a small power supply in your circuit. So you're going to drop down the batteries, and you're going to use a little 9-volt battery. I'm not real happy with the size of it. It makes it look huge, but it'll work for this example. To change the angle, you can just click up here on the arrow once the item's selected. Use your roller mouse to kind of scroll in and out. So you got a 9-volt battery, and you got three bulbs. You can spend a lot of time with this. So we want to connect these wires up. So I'm going to hook the negative terminal. That is actually a negative terminal. And we're going to hook it over to this last bulb. And the way we're going to wire that up is we're going to talk about wire color. So I'm going to select a black wire for negative. You're going to click on the negative terminal, and then you're going to have this wire drawing function. So I'm going to come out to about here. I'm going to come over on the page maybe to about here, and then I'm going to come up and connect it to that terminal. So again, just put a negative jumper wire there. I'm going to wire the rest of these up in red. The significant positive, so I'm going to go positive wire over to here and attach the terminal, and then I'm going to reconnect. Now what I'm going to do for in between the bulbs, I'm actually going to change this, and I'm just going to select green just to indicate that they're not positive. Oh, that actually turned green. I want to make that red. Sorry about that. So let's turn that back to red. So what I'm going to do is I'm going to take the rest of these wires and I'm going to attach these and turn these into green. So I'm going to connect that one up. And I'll connect this one up. Doing this real quick. I'd probably spend a little bit more time with this in class. So there's your 3-bulb circuit. And most of you agree that this is actually a lot easier to see than a bunch of wires running across the bench. Make that green. Okay, there's your circuit. Now this is where I really think the power of this software works. You're going to come back up here to the top right-hand corner, and you're going to click right here where it says start simulation, and that's going to turn the 3 bulbs on. Okay, so then the cool part about this, now we can test this circuit live. Okay, so I'm going to stop the simulation, and I'm going to drop down, and I'm going to grab a meter. Now, when you've seen me do this in class, this is usually where we run into problems because all the students will have different meters and all the students will have different settings, and then maybe they won't have the leads on correctly, so they won't get things that they can understand. So this meter can be a voltmeter, it can be an amp meter, or it can be an ohm meter. So you got a resistance in there too. So I can teach what I call the big 3. And with these circuits. So what I can do right now is I'm going to go ahead and connect this up as a voltmeter. I just want to measure voltage coming into that first bulb. So what I'm going to do is I'm going to go ahead and connect my black lead from my terminal, from my meter, and I'm going to bring that around. I'm actually going to go all the way around the battery, and I want to overlap. I probably should have left myself a little bit of room here, but I'm going to hook that up to the negative terminal. And if you've been to my class, and we know that the negative terminal of the battery is the only good terminal on the circuit. So your negative terminal, the negative battery is the one you're going to use. I have selected this, I believe, is a voltmeter. I can click and make sure it's volts. Now I'm going to create a red lead for my meter. And what I'm going to do is I'm going to put that red lead, and I'm going to put this on that first bulb. So again, I probably should have given myself a little bit more time, but there it is. There it is right there. Whoops. Didn't quite hit it. So I'm going to escape out of here. Try that again. And I'm going to go over the top of this one, and I'm going to come right back over here, and I'm going to go right to that terminal. See here it lights up the terminal? That's when you know you got a good connection there. Okay? Now this is where it really gets cool. We hit start simulation, and it's showing the battery 8.91 volts. So the battery's almost fully charged, but it's actually showing the voltage at that point. So my question for the student is, as the circuit's powered up in series, what happens to the voltage as you go through the circuit? It drops. Okay, and that's a main subject matter that we teach. So to prove that, I am going to put another voltmeter. This is the advantage of using Tinkercad. I don't have to have 3 meters to do this activity. So I'm going to go back with my red lead. Okay, I'm going to stick with the red lead. And my red lead is going to go to the second bulb. Now, again, as I draw this in class, I'll probably spread this out a little bit more, giving them a little bit, but this is definitely better than a bunch of jumper wires across the table. And there's your second meter. I got to give this meter a ground, so I'm going to change that to black. So I'm going to take this black lead, and I'm just going to do this. I'm going to go right up over the top of here, come all the way around, and again, make it as clear as can be. Work this all the way around the outside of the circuit. Come right back to my negative terminal. Once I get to it, it's going to tell me I'm connected. Okay, so now I'm going to go ahead and simulate this again. I ask the students what they think is going to happen, and they can see that that first bulb drops about 3 volts. So that bulb's going to use 3 volts. This one's got about 6 volts, so it's 9, 6. And how much do you think is going to be left for that last bulb? Let's find out. So we're going to do that. We're going to do the positive leave again. We'll need to change that to black. Oops, escape out of there. Change that to black. Or excuse me, change that to red. I'm going to take my red lead. And again, make a little bit more sense to the student. I'll come around this way. And I'll come right down on that terminal. There we go. So there's my ground. And then we're going to give myself a ground. Black lead. Negative up here. And again, you're not going to have 3 meters on your car, but to understand how to do this, we're going to run these wires all the way around. So I do this in class, but you can just do this with the batteries and bulbs. And whoops, let me spread my circuit out a little bit. Get back to that terminal. There we go. At this point, we're going to go ahead and start simulation again. And there's your 3 volts. So you're going to see a 3 volt drop across that circuit representing the equal. So I can tell you that each one of these. Now, another thing that's really neat is you can actually come up here and hit schematic, and it shows the schematic of the circuit we just did, which is really kind of cool. Okay. Now, another thing you can do with this is we can change the meters around. So if I want to change this to an amp meter, an ohm meter, whatever I want, if I want to put different devices up here, if I want to put, switches, relays, I can put a fuel pump. I can have a student draw a fuel pump circuit with a control switch. We've got slide switches. We've got potentiometers. We've got all kinds of different little doodaddies we can put in here. We can also take just the same circuit and we can put a failure in there. Okay, so we're going to put an ohm meter in there or put a resistor in there. And this is, let's say, if I'm going to change it to ohms, and I'm going to put, let's say, 500 ohm resistor in there, and I'm going to make that 500 ohm resistor as part of the ground. So let's say we've got a green corroded wire. So now the green corroded wire will be this wire. So I'm just going to eliminate that. And I'm going to say, okay, well, now my circuit has a ground with a high resistance, in this case, 500 ohms. And I'm going to go ahead and put the resistor in the circuit wherever the heck I want to put it. So there's our circuit again. So now we're going to say, okay, what would happen? Start simulation. And at this point, the bulbs, you can't hardly see it, but they've actually decreased in intensity. But you've also noticed that your voltage drop is less. And that's because you added a resistor to the circuit. So all of those concepts that I've tried to show on the board with my terrible drawings and with my bulbs and my jumper wires and stuff like that can now be simulated with this software. And it's just a cleaner picture. We can also export this picture. So let's say if this is a great example, I want to put this in a workbook. I can go up here and I can send to, and I'm going to send to What am I going to send this to? I'm going to down arrow this, and I've now created a file. Whoops. Wait for it to open. Let's see. Send to picture design. Okay, so I've actually put it into a download, so I can actually print a picture of that. Obviously I'll get I'll get that a little figured out for you guys. But the cool part is you can actually go in and look at simulation, and this will actually show you the resistor where it's located in series with the bulbs. Amp meter stuff, again, you can simulate anything you want. We can run motors, we can put resistors in here, we can put variable resistors in, we can put push button switches in. I can do a lot of training right off of this. And then the student, we even have oscilloscopes, power supplies, generators, a lot of different things that we can do. So we can have some fun with this. For you as your technicians, for me to go in and teach this, it would work best if each one of them had their own laptop. If not, I could do this as a presentation where I just use this as my normal, my normal projector. I need a projector, a screen, or a TV set that I can bring this up on. I can run this on my laptop. I can give you these simulated drawings to you where they can work on it. All I have to do is stop the simulation and let them answer the questions with the, components. It really just allows them to do what we normally do with the breakout boxes, but we don't have to worry about blowing fuses or having enough meters for everybody. But this is kind of what I thought about, and this is the kind of thing you're looking for as far as an electronic class. I could spend some time working up some curriculum with this. I could see where this would be a multi-night class. Obviously, we could work with these meters, but eventually we want to put a fluke meter in their hands so they got a meter to work with. But we have all these different components. Now, the automotive stuff makes sense. Let's see, power supplies. I can bring a 1.5 volt battery out, and I can actually increase the battery count. And I can actually, build a 12 volt battery if you want. If you want to stick with 12 volts, 9 volts is fine. But you can go in here, and we can also use breadboards. Not used a lot, but I may actually use this in some of the more complicated ones. O-scope, I haven't really played with that, but we're not going to do like sensor circuits. Maybe we could, as we move down. But relays, I'm not 100% happy with the relays that they give you in here. They're not a normal ISO pin relay, but I'd have to create a schematic for that and then give that to them so they'd understand how that relay functions. But there's nothing that, there's really no reason. Here's their single pole double throw relay. So that's a pretty traditional relay, but if you look at it, you really have to look close to understand pin configuration. These two pins here would represent these terminals. This is your coil of your relay, and then this is, I believe, your normally common. So this would be, I'm thinking maybe this is 30, this is 87A, this is 87, and then this is was 85, 86, I guess, something like that. So yeah, so we can do relay stuff with them too, which is kind of cool. We can actually build some circuits around this. We can do a starter circuit. There's a lot of stuff we can do with this. Micro switches, DC motors. You can bring a DC motor out. Not a lot of changes. We can actually, if I run a DC motor, let's put another 9 volt battery out there and just run the DC motor. Kind of show you what that does. Let's see, where's my batteries? There's my battery. So let's stick another 9 volt battery. I'll turn that around. Bring it up close. Just do a jumper wire to the 9 volts. Yeah, well, we'll change the polarity backwards. That's okay. And then we just sit there. Whoops, didn't quite get on the terminal that time. And then we just go ahead and start simulation, and then a motor runs. There you go. So I can do all kinds of different things. If this is something you guys want me to pursue, let me go back to my Zoom meeting here. If this is something you would like me to consider working up, something you guys like to do, I'd be more than willing to work with you on this. I'm going to be off for, I think I've got 5 or 6 weeks off for Christmas. Right now, I'm really busy at the college. I've got some time over Thanksgiving week I'm off. but pretty much during the school year, I'm very busy. But this is something you guys are interested in, take a look at it. You want me to come down and demo it for you? Let me know. But yeah, I would suggest looking at this for your guys. So, all right, if you have any questions, give me a call, 315-466-6649. Thanks, guys. Take care.